Okay then, question 5 is a real beauty, I love it, and the assess. Right, it says a tennis court is an enlargement of the table tennis table, so that's the little one, that's the big one, and the tennis court is similar to the table tennis table. One is the enlargement of the other. Please note the use of these words. If two shapes are mathematically similar, and I've used that in a previous video, then one will be the enlargement of the other. Okay, so learn these words, enlargement and therefore similar shapes. Work out the scale factor of the enlargement. Well, I've got the 1.5 to work with, and the 10.5 is the corresponding length on the tennis court. So part A, let's get the scale factor. It's going to be 10.5 divided by 1.5, and I know the answer to that is 7. So that's 7 times as big as that one there in terms of the corresponding lengths. Work out the length of the tennis court. Well, I'll take my 2.8, multiply that by 7, get an answer quickly. That gives me 19.6. So if I put 19.6 meters there, let's just show it by calculation. So 2.8 multiplied by 7 gives me 19.6 meters length across there. Work out the area of the table tennis table and the area of the tennis court. Okay, let's just do table tennis first. What have we got? We've got 1.5, the width, and a length of 2.8, and that gives us something. 1.5 times 2.8, that gives me 4.2. So 4.2, and it's meters squares because we're talking areas now. And now the tennis court itself, same calculation, we just have a bigger rectangle. 10.5 multiplied by 19.6, and the answer will be in meters squares again. Get you an answer now. 10.5, 19.6. Boom. 205.8, yeah, meters squared. Now, last bit is very interesting. Work out the ratio of the area of the table tennis table to the area of the actual tennis court. So if I go table tennis dot tennis court, I'm going from little to big. So the areas now, ratio of areas, I've got 4.2 compared with 205.8. Now I want to get it in the form of 1 to n. How do you get from 4.2 down to 1? Answer, you divide both parts by, not 2, 4.2, excuse me. So dividing by 4.2, this is what I'm going to get. Get ready? 4.2, divide this side by 4.2, and whatever comes of it, comes of it. Well, 4.2 divided by 4.2 is obviously 1, and 205.8, divide that by 4.2, I've got exactly 49. Now, that is really interesting. So the ratio of their lengths is 1 to 7, but the ratio of their areas is 1 to 49. It's not a coincidence that 7 times 7 is 49. Now, we're looking towards grade A with this kind of discussion. I'm not going to talk about it at foundation level where we're looking at top grade C, but it's just an indication for the future for anyone who may want to do the higher paper. So that's it on the assess. But I've chosen the question 2, the AQA style question, and I've got it on the background there. It says copy shape A onto a grid. No, I've done that. Enlarge the shape by scale factor 2. Okay, let me use my pen facility. And there's no, if you look carefully, there is no center enlargement at all. So I'm going to start drawing it randomly here somewhere. 1 square up times 2 becomes 2 squares up. So you're allowed to work now. 2 squares up. 3 along becomes 6 across. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 squares up becomes 10 squares up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's a bit wobbly. Then just join the ends and let go. Right, that's enlargement scale factor 2. label it B for some reason, so let's just listen to them in case they start to moan. That's the enlargement's B. They should call it A dash really, because A dash is the image of A. Right, please watch this. This requires a red pen. I'll tell you why it requires a red pen. They've got a word here. Which of these statements are true? Is shape B congruent to shape A? Congruent means identical shape and size. Answer is no. Now I'm getting really glitchy. So no, they are not identical. They are mathematically similar because B is the enlargement of A, but they're not congruent because they're not identical in every way. The angles of shape B are the same as the angles of shape A. That's put a tick there for true, because when you enlarge a shape, all the angles stay the same. You've got the right angles there and there and there, and whatever this angle is matches that one, and whatever this angle has become matches the original there. Alright, so I'm trying to show it with a different set of curves there. So the perimeter of shape B is twice the perimeter of shape A. Yes, if that's become 3 across the bottom and that's 6 across the bottom, everything is enlarged by times 2 in terms of the linear lengths of all the combined lengths. Bit of a mouthful. Basically, it's true. The area of shape B is twice as big as the area of shape A. No, not true. You can see straight away that if you just count the squares alone, there's more than twice as many squares here than here. I tried to show you in question 5 that in fact when you enlarge something by scale factor 2, the area goes up by 4 times as much. Won't get into that because that's grade A, but basically if you enlarge the lengths by times 2, the area doesn't go up by times 2, it goes up by times 4 in fact. So I'm going to stop there, and that's part 14 done. I'll get editing and put these on the site as soon as I can.